This is June 2016, paper 2PR, and this is question number 2. The student is given an unknown electrical component, which I'm guessing is X here, and uses a circuit to investigate how the current in X varies with the voltage. Which of these circuits is the correct for his investigation? So let's have a look through them. Let's start at D. So we've got a voltmeter in series, which means that no current will flow, so it can't be that one. C, we have an ammeter in parallel, which means it won't be able to read any other current, and it's also in series with the voltage, so it's not going to be able to read it either. B, we've got a voltmeter in series and an ammeter in parallel, so they're in exactly the wrong places, which leaves us with A to be the answer. The next thing it asks us to do is plot these table of results. So we're plotting a graph, and it should look something like this. Now when you're plotting a graph, they're looking, if it's 4 marks, they've taken off a mark here, normally it's 5, they've taken off a mark because normally they ask you to fill in those labels. So for 4 marks, they're looking for a scale, making sure that you use over half of this paper. If you do it tiny, so it looks like this, you're not using enough of this graph paper, so the scale would be wrong. And then you're going to plot those 6 points, and you get 2 points for that, and they'll do within half a small square of where it should be. So you've got to be really precise with these, so make sure your scales are right. They'll take off a point here for every one of the points that you plot incorrectly, so making sure you're plotting all of them correctly. And then 4th point is for a curve in order to go through all of those points. Some people are going to try and draw a straight line, but it is of course a curve. The next thing is state the equation linking voltage, current and resistance. That's very easy. V equals I times R for 1 mark. Calculate, so we've got to show our calculations, and look at this, it's a 4-mark question, so there's lots on offer here. Calculate the resistance of the component, so the first mark would be for rearranging correctly, of course. The voltage is 10, and calculate the resistance of component X when the voltage is 10. Now, we don't have, if we look back, we don't have a voltage of 10 so to get a current out of it. So what they're asking us to do is go to our graph, go up, and then across, and then read off what that number would be for the current. And you should have found that it was about 1.6. They would have give you half a small square either way of that as well. So then we can rearrange, and we've done that, and we can get that the resistance is 6.3, and then the correct unit would be ohms. So 4 marks on offer there because you were meant to notice that there was no resistance for 10 volts, was no current for 10 volts, so you had to use your graph in order to read that off. And then they're going to describe the pattern shown by this graph. So the first thing we could say is V increases, let's spell it correctly, I increases, and that the gradient constant grad at first, we could say gradient changes at high voltages, and we're only looking for 3 marks here. We could also say that I is proportional to V. You're meant to get that at first it's proportional to each other, and then as the voltage continues to go up, the current, the rate at which the current is going up, starts slowing down. Suggest a conclusion for this investigation. Well, they're looking for 2 points for this conclusion. Resistance is constant at first because is constant, and the resistance is constant because in this case it's not that the gradient is constant. V is proportional to I. If it was a gradient, you would say the resistance is change in V over change in I. It's not that. It equals V over I. It's that whenever you take a point along that straight line, V over I is the same number each time. It's nothing to do with the gradient. It just happens to be the same when they're proportional to each other. But as it changes in this portion of the graph, R you'd still have to do R equals V over I, but now the resistance seems to be going up because there's less current going up through it for every change in the voltage. So resistance is not constant. Resistance is not constant. Therefore, where's that coming from? Because X gets hotter. So as it gets hotter, the resistance goes up. So you need more voltage in order to get the same amount of current through it as you did before. So X is a filament lamp. It's a very distinct type of graph for a filament lamp. If it was going down the other way, we would see it do that. So this you should recognize as being the graph for a filament lamp. And that's question number 2.